Here we're applying a function to that detection model, in particular the to function first and the float function later. Okay, so if we step into this and we call the to and the device, we jump into the _apply method. Now remember that detection model, which is defined right here, we are inheriting functions from base model right here at the top, inherits from n in that module. Submodules assigned in this way will be registered and will have their parameters converted to when you call, for example, the to method. And that's exactly what we did. So when we call the to method, n in that module calls an internal function, the _apply, that applies transformations like this one or other ones to model tensors. So in this case here, we're applying this internal method to the n in that module. Remember, self is the detection model, and here in self that model, we have the sequential. The sequential has a number of modules, and in particular, we want the last one. We want the detect module. So M is going to become the detect module. So M just got created right now. And here, we're checking if detect or segment are part of M. Well, we have detect, so we step into that. M.stride right here is assigned to that device. In our case, it is, but we could have had another device like GPU or MPS, making sure that the information is in the right device. In our case, it won't change, but it's a good check to do anyways. M.grid right here. Again, the different tensors are also in the CPU, but if they weren't, they would be assigned to that device. And in a similar fashion, M.anchor_grid right here. I'll just pick another one this time. Again, assigned to CPU. In our case, it's checking first if anchor grid is a list, which it is. So we step into, and then we make sure that we have it set up to the right device. Then we return self. And now we've run these, but now we're going to convert the different tensors to float32. So we're going to step into the function apply again. But in this case, we're not focusing on the device. Instead, we're focusing on the data type. So again, this applies. And now notice that stride is right here. Now stride, it was imported as half or float 16. The moment we run this will be converted to float 32. And the same with grid. Right here, this will be converted to float 32. And yes, our anchor grid is a list. So we'll step into it again and we'll convert that to float 32 as well. And we'll return that. Now, the moment we run this, CKPT, which right now is a dictionary of different values, will become whatever we have here in CKPT model. So you'll see that CKPT will become a detection model. We run this, and CKPT now is the detection model with, of course, all the information that was loaded in the detection model. Now we're going to do a few checks for model compatibility. If CKPT doesn't have the attribute stride, well, we do have it, so we step over that. If it has the attribute names, we do. And if that is either a list or a tuple, it's a list. Well, in that case, convert that to a dictionary. So instead of a list, where each index represents the index label and then the name of the label, convert it to a dictionary. So names now is a dictionary.